Because at the end of the day, it is not a one single engineer who's doing something. It is a team effort. You need to work with people. You need to be a good people person. You need to be empathetic to others' pain. You need to willing to accept and work with other people. That kind of, the basic human quality, it is so important. As an engineer, you think that you are the smartest person in the room, but that's a wrong attitude, right? So having that human quality, I think, is one thing that if you ask me now, what's the most important thing then when I look at somebody, it is not about their brain power. It is about their people power.
Hello, everyone. Welcome to the It's a Material World podcast. I'm Puneet. I got my co-host David joining me today. What's new in your world?
Oh, well, I recently read an article about upcycling of NMC powder, and so it kind of goes with today's episode. But a big part of batteries is what do we do once they're dead almost, and we can't use them in our phones or our laptops anymore. And so this paper goes over how we can take old NMC and then put it into new batteries with basically the same performance with just quicker fade, meaning that it won't last as many cycles. And so that kind of leads us into today, where we talk with Fred, who is a CEO of a KTON, which is a battery company mainly focusing on bringing knowledge over from Asia to America. And so we talk about battery recycling and what they're doing as part of it and how the infrastructure will look like in the future. And so I think that we've talked before about what actually makes up a battery, but I think today we talk a lot more about how are we going to get to America being completely electrified, and recycling, and he also does testing are really important steps on that process. And
Yeah.
so maybe what was your favorite part of the episode?
Yeah, it's definitely a shift from kind of episodes we've done in the past where it is, for me, it was like this shift in perspective and recognizing that other countries, especially in Asia, may have more expertise and experience in terms of battery testing, mass production of battery cells compared to the US. Because historically, a lot of that production happened, globally or outside of the US. And now it's starting to shift into battery startups and even the likes of Tesla, right? So I think it was just very eye-opening for me that the US does have a lot to learn. We're not number one in everything. And so that was kind of that was really cool. And I think this episode really talked about like what does battery testing infrastructure look like in Asia versus here, and it's just a reminder that we have a lot of room to improve and grow. What about you?
Yeah, I know, on the same chord, it's just how like progress differs between us and Asia as the involvement in industry of the government. And so
Yeah,
in the US, it's very laissez-faire, where there's a need, someone will meet it. Whereas in Asia, it seems like the government will do the dirty work in terms of building out infrastructure of the less profitable sectors to enable the more profitable sectors to rapidly like progress. And so I thought that was a very interesting way, and not saying one way is good and the other way is bad, but it just kind of shows how different approaches lead to very different results. But I think what Fred does really well is talks about how we can bridge the two. And so we may have two different systems, but we can take learnings from one and apply to the other, and vice versa. And so I think that was really interesting to talk about as well.
absolutely. And Fred has that materials engineering background, and he's way more involved in the business now, obviously as CEO. But he really gives great advice at the end of the episode in terms of how, even as an MSc, you can be more of a well-rounded candidate so that you can drive impact in any industry that you work for. So yeah, without further ado, let's get into the episode.
Meta Material Inc. is a developer of high-performance functional materials and nanocomposites. Meta delivers previously unachievable performance across a range of applications by inventing, designing, developing, and manufacturing sustainable, highly functional materials. Meta is a fast-growing company with a positive and committed work culture and a phenomenally talented workforce. Our employees are inspired to do exceptional and innovative work and are proud to contribute to the success of the company, and they are our greatest asset. Meta attracts people from all countries and cultures with over 35 spoken languages represented across all our teams. Meta believes that diversity drives creativity and innovation. With locations in Canada, the United States, the UK, and Greece, Meta is growing and is looking for new talented people to join the team. If you're passionate about doing your best work, making a difference, and having fun while doing it, apply to one of our open positions at metamaterial.com/careers.
Hey everyone. So for today's episode, we are excited to welcome Fred Lee, CEO of KTON LLC. Fred was educated in both South Korea and the US, where he studied materials engineering, mathematics, computer science, and business. As CEO of KTON, Fred plans to ensure that the US plays a leadership role in the EV market through battery safety and sustainability. Super glad to have you here, Fred.
Well, thank you so much for inviting me today. Appreciate it.
Well, yeah, I think that in the past few episodes, actually, we've talked about batteries on the show and the materials that make up a battery system. But one thing that we haven't really focused on is the end of line, and that's the testing the batteries to see the performance as well as the safety. And so could you give us, from KTON's experience in this area, how batteries are tested and why it's so important to do that?
Before we talk about that, maybe I'll talk about the KTON a little bit so that the audience understands the business buckets that we are in. The KTON, we have two business buckets. One is we are partnered with about a dozen and a half technology partners from Asia, from Japan, from Korea, from China. We are centered around testing equipment and services, but now we expanded into the manufacturing machinery, design of batteries, also the commercialization of it, pack assembly, things like that. Also a little bit of material side as well. So that's a bucket number one. We're bringing the technologies, the equipments, the know-how, the expertise that have been in Asia since the beginning of the lithium-ion batteries 2-3 decades ago from Japan. As you know, it's Japan who started it. We went to Korea, and then the China is really took it to the moon. So it's very important for us to bring that know-how and experience into the United States, because unfortunately, as you know, the US is at the end of this battery evolution. The electrification is so important now with the government pushing for the manufacturing to be back on US soil. It's important that we embrace our friends from Asia to kind of help us to build the infrastructure in the United States. So that's our bucket number one. Bucket number two is because of all that onshoring going on right now from Asia, particularly from Korea, because if you look at all the battery cell manufacturing at the mass scale, LG Energy Solutions, SK Innovation, SDI, Samsung SDI, those are all Korean companies who are joining up with the American OEMs, the GMs, the Ford, Stellantis, and others to really enable the electrification in the United States. So there's that vertical of the battery manufacturing know-how. There are a lot of companies, in fact, if not all of them, that need to be come to the United States and have factories and businesses established. So our bucket number two is also to help them. It's foreign direct investment, right? So that journey of foreign direct investment into the United States is not so easy. You can imagine being a foreign student coming to the US to study. That's difficult in itself. But if you're a company coming to the US and starting a business and make it sustainable and be successful long term, that's a difficult chore to have. So we would like to help them to make sure that their journey to the US is easy, simple, plug and play. So that's we are set to do that. So we are teaming up with the state governments to help them to come to the United States. And your question was, what was it? I'm sorry.
Yeah, so thank you for giving us the background on KTON. I think that's really interesting. And just a side note is that, like Tesla has partnered with Panasonic, and a lot of the mature wet processing of batteries is mostly done by these Asian countries. And so I think it's really interesting that now with the mandate of manufacturing in America, we're bringing all this innovation and technology over. And so now that you've given us that explanation, could you explain how batteries are tested and why they're so important?
Right. So the batteries are tested in every level of the form factor, right? If your battery cells, small pouch, prismatic cell, the cans and so on, there are a series of test methods that have been developed. In fact, Sandia National Lab was sort of the grandfather of coming up with the standards, safety standards. And the rest of the world have their own standards and test methods and so on. The China actually has the most advanced testing methods and methodologies. So since earlier last year, we embarked on understanding of the infrastructure, the testing infrastructure of the United States, especially for the larger format batteries, because cells and those equipment to test those are they are available. So you can do a nail penetration, you can do crush, thermal events, thermal runaway, the thermal shock test, the life testing, the cyclers, and so on. So the small ones are okay to do. So in fact, we have testing laboratories in the United States who can handle those. The big pain point, however, is for the larger format. So look at, for example, if it's modules and skateboards themselves. We sat down with so many hundreds of stakeholders in the United States, the OEMs, the battery manufacturers. These safety standards, safety tests. It's also called the abuse test, because you need to abuse it. You need to push the envelope of the operational condition to see what happens in an abnormal situation. It's going to catch a fire, it's going to explode, things of that nature. So the abuse test is a safety test, right? So it's important to have that. A UL also has that aspects of their testing protocols. The DOT has it also, the transportation side. The UN also has some of those testing protocols. DOT obviously has them. The problem is that we simply do not have the testing infrastructure for those larger format batteries. For example, if you have a Tesla, you need to drop that big, skateboard, right? It's one of the tests they have to do. You have to crush them. You have to do a thermal events. To do that, you need what's called the bunkers, because you will have an explosion, you will have a catch fire, so on and so forth. The testing infrastructure is lacking in the U.S. So what people do now, that's a huge pain point. In the United States, as far as we know, there is only about 2 or 3 facilities that can accommodate that. And we sat down with the president of one of the largest battery manufacturer, the name that you know well. They have manufacturing in the Midwest. So to do those testing, they have to drive all the way up to Canada. The companies that are in California, the electric vehicle OEMs, the new ones, they have to drive all the way to Texas for these type of testing. So we need to have more infrastructure. We need to have more testing facilities for a larger format. So that's a concern. And that's why we have an initiative within KTON to educate the audience and so on. Because, we can, we already hear the incidences of catching fire, right? In fact, today I was talking to somebody, they're making a Second Life battery as a ESS, and then they're putting it in a part of the grid, and it happened to be a nearby somebody's house at a residential area. And now they are saying that don't put that, ESS in my backyard, because I've seen them, catching fire. So it's so important for the electrification industry to really take it, smooth transition, have the consumers embrace it without having to concern about the safety. We need to test them, right? That's where we are in the US, and we need to ramp up.
Yeah, so you mentioned a lot of safety standards, and to break that down, it basically comes down to a few factors. You have to penetrate the cell to make sure that if it shorts, like what happens, and you have to crush the can to see how much pressure it can do, and all these other things. But I think an interesting note and something you can touch on more is that there's different standards between a single cell and a pack like he's talking about, and it has to pass both. And then shipping is a whole other issue. And so maybe could you elaborate on when we have and we're trying to scale up to all these cells produced in America, what does the bottom line look like on terms of how many out of 1,000 cells, how many do we need to test for each plant? And then how does that scale up And so what is like the final effect of like if we want to make an electrified fleet in America, what does that actually look like for us as consumers?
Well, that's a good question, and I don't know whether I have a single canned answer for that because
Mhm.
every OEM, if you look at the instead of looking at the electric vehicle, the battery side of it, let's look at the automotive industry.
Sure.
Automotive industry been around for 100 years, so they have in the automotive industry already have a set protocols for testing for quality, right?
Hmm.
So there are two largely different categories of testing. One's called the design validation
Hmm.
and the other one is called the production validation. So during the design phase of it, make sure your design is done to the specification that takes care of the safeties, the performance, the reliabilities, and things of that nature. So that has to be done during the design phase as a DV, we call it design validation test. And how often, how many cells out of 1,000 cells, that's all up to the each individual OEMs to have what is your own criteria, your own set of bars that you establish as a quality system. The production side is the same thing. How many samples you're going to pull out of how many production units, right? So those I cannot, mention exactly what the quantity of it is, but those standards are already protocols are already in place because of nonetheless it's electric vehicle. It is an automotive, so automotive industry has a very good system of ensuring the quality, safety, the reliability.
Cool. So you mentioned like the buckets, right? That KTON focuses on, and they're related to kind of bringing, the knowledge base in Asia and the expertise kind of to the U.S. So I was just wondering, what are some of those generally the differences in the ways companies in the U.S. operate versus in Asia, and kind of like in specifically with the battery industry.
Well, the thing is, right now the mass production side of the battery industry is all done by foreigners at this point, right? It's LG, it's a Samsung, it's SK. Those are the ones who are actually putting all the batteries, and Panasonic for that matter, right? Are the ones that are putting the batteries into the electric vehicles right now. The US side, we work with quite a few of the startups.
Hmm.
So US is a nation of startups. So and we have too many smart people, develop something in the university labs, and then they go off, and then they start your own company. So and then they are fully backed by all the investments. So it's exciting to see all those startups, starting out, with a lot of innovations and so on. But what's lacking is the know-how to take it to the next level of mass production, for example. So the commercialization aspects of it. So one thing is to make it in the lab, but being able to make it in the production and compete with these gigafactories, right? So unless they get into a very specific uh, category of the batteries and the mobility industry, being able to compete with the gigafactories, that's going to be a difficult thing. So one of the things that we are trying to do is also one of the partners that we have from Japan, the group of scientists and engineers who are in fact the inventors with the batteries at NEC, for example. They are the ones who have developed the Nissan Leaf battery systems and so on. So we also want to bring that expertise uh, to enable our startups to be able to take it to the next stage in the commercialization.
And so, why do you think it's important to understand an industry from a global perspective? Obviously, you can cut down time and research, but what do you think like the most important factors are of being able to take learnings from Asia and take it to these startups? And like, what does that result for the startup almost?
Well, it's going to accelerate them, right?
Hmm.
So they do not have to go through all the trial and error. If there's
Hmm.
some good teacher can teach you how to, sprinkle some magic dust on your recipe, then you will get to the next stage faster and faster and faster. Because we need to ramp up. We already have a cell shortage for sure.
Hmm.
I can give you an examples of all these gigafactories. They cannot make it fast enough. So it's important to help the US side, especially the startups, to be able to go to the commercialization quickly. And also in terms of the machineries to make batteries. Unfortunately, US, not only the battery side, but US has thrown a baby with the bathwater in the 80s and 90s. We really do not have a lot of manufacturing infrastructure. We have to import almost 100% of the machineries to build batteries from foreign countries right now. China, obviously, but the stance that we right now U.S. has against China, that we already seeing that impact on bringing technologies from China. Japan, although they started it, the price couldn't compete with, say, the Koreans, the Taiwanese, the Chinese. So there's a lot of focus on Korean machine builders right now to be able to build lines for the battery manufacturing in the U.S. So that's kind of how the agents can help. And these countries are allies of U.S., so they're very much willing to help and onshore to the United States.
Interesting. And so I know you mentioned you brought up the infrastructure side, so I want to dive into that a little bit more. I know you mentioned like companies in California have to travel to Texas. So what are kind of those like next set of obstacles that maybe from the materials engineering standpoint or even just like the business standpoint that people can or that this industry is facing that prevents us from like scaling up and having that stronger infrastructure within the US or maybe more facilities for testing, for example?
So I think it's two different things. Let's look at the infrastructure for manufacturing is one thing, but infrastructure for testing is a separate, right?
Yep.
So I think a lot of this quality, the U.S. is a little different from other nations around the world, where we really leave it up to the industry to develop infrastructure, right? For example, the peripheral infrastructure, just like testing, for example, right? It's a little different in Asian countries and some of the other, some are more, planned economy, if you will. The governments step in to build this type of infrastructure for you, so that the industry can focus on developing and making and manufacturing. They do not have to go out and build their own testing facility. The government will come in and provide the testing facility for you in terms of the subsidies and so on and so forth. So that types of infrastructure is very well established. For example, countries like Korea. And Korea is also very much planned economy. The government leads where they need to go as a country, especially so much depending on export. So the government is the conductor, right? Whereas in the United States, it is completely, the government doesn't even want to step in because that's the commercial space. That I think is part of the problem, because when it comes to a infrastructure, the R&D, the testing, those are not the profit centers for the companies, right? Those are the auxiliary functions that companies needs to have, but it's not a profit center. So the companies tend not to invest on those unless it's completely necessary. Unless somebody is twisting your arm, the industry is like you know what I mean. So they can. So we have to rely completely on the commercial side, commercial sector, the private sector for the testing. So all those names, the TUVs and the Intertext, so on and so forth, that are providing those testing. The problem is some of these abuse testing are not as the profitability for those type of testings are not really there for testing labs to establish themselves as an abuse testing facility. It is not as often needed because it may be needed in the design validation cycle. So it's not something that if they buy a huge vibration table, that's going to cost them $3 million. That fits the entire skateboard, but they can only shake it maybe once every day, if that often. So they tend not to get into that side of the business from a commercial testing industry perspective. Meanwhile, the companies do not want to spend that much money for testing on their own. You can imagine, right? If they don't have to, then why do they want to do that? So that's what the problem is. The U.S. is completely different, way of thinking. The philosophy, the government says, they can, have grant programs and whatnot to help the entrepreneurs and the industries to grow, but you cannot imagine U.S. government setting up a testing lab. That just it's not going to happen. I mean, we have a federal laboratories, right? We have federal labs who provide, but they are not a commercial sector lab. They are not commercial lab. You cannot send samples to Sandia and ask them to test it and then give us a stamp of approval, right? They're more of an R&D arm of the government. So that's a little bit different. Looking at ASTM, SAEs, I mean, those are typical test standard organizations. Those are private organizations in the United States. ASTM is not a government driven, right? The American national standard is ANSI, ANSI, right? And those testing methods are all adopted from the ASTM developed test methods or SAE test methods. Those are all industry driven. Whereas all the other countries, look at Germany, it's DIN, that's a national standard they actually develop. If you go to Japan, it's a JIS, that's a government-led standard organization. Korea, KS, same thing. You go to China, it's a GB standard. So US is quite different in that approach of the government's role in developing an economy. So, but now with the new industry, government is rather slow moving in, but government is spending money to build the infrastructure, such as charging stations, right? So, and then we want to have all these companies come over, start manufacturing in the United States. It's like building a brand new subdivision, but we are building it without hospitals, police, or schools. So,
Interesting. So what do you see as that like solution? I mean, you mentioned, you might not see that the US government kind of getting involved like super quickly, or it might take a while. So what do you see as the solution? More private companies focused on the testing space, or what?
So there are testing laboratories, testing houses. It's called the TIC industry, testing, inspection, and certification industry. They're building up because we sat down with the OEM in Michigan. They already have their own testing centers for batteries and so on, but they told us they're already at full capacity already. And you can imagine that how many EVs are coming out from GMs and Ford. Not many, and they already spent millions of dollars building their testing facility, but it's already full. It's already saturated, so they have to go outside. So I think it has to be collective. I think it has to be a public and private effort together. Also, the consumer side also have to kind of alert the industry or the public or the governments to say, hey, make sure that the electric vehicles are safe. You have to show it to us. So I think it's a lot of awareness that needs to happen. I don't think people, testing is not very sexy, right? So nobody talks about it. And then some of these testings are, it's a fire, it's an explosion. So, so I think it has to be a concerted effort by the government, the industry, the public, all that. And then at some point, somebody has to fund this, right? Because the private industry is just not going to find it profitable enough to ramp up the infrastructure. So how can we do it? We have to be a little bit more. Government doesn't want to get into the private sector business, but we have to find some middle ground here, I think. Otherwise, we have to continue to drive to Canada, and then they actually test it outside. So they're gonna catch fire. The thermal events is all done outside, which we simply cannot do that. We have in the United States, I mean, no matter how remote location you go to, we have an environmental concerns and so on. So I think it has to be a concerted effort. It has to be we have to work together with public sector as well.
So it sounds like there's a huge bottleneck, and usually when you have a bottleneck, you can solve it through either making more infrastructure, which I think you've laid out very well, but you can also make testing faster or smarter. On that front, could you give us like maybe a rough estimation of how long testing takes now? And are there developments, or is it really just building out infrastructure to support the demand?
Well, on the safety side, there's a very good article that was written by Dutch folks a couple of years ago, just comparing all the different types of abuse testing. There are a series of abuse testing, right? So there's the environmental side, electrical, there's a mechanical, there's physical, and then there is also the fire side. So the suite of testing, it requires dozen and a half different test methods, test protocols. And some of these testing, these are abuse in nature. So in other words, they're mostly in physical tests. They're gonna nail penetration, or they're gonna drop it, crush it, tilt it, so on. So these are type of testing that really does not take that much time.
Mhm.
So there's no such a thing as making it faster, because you can penetrate a nail. How can you? That really doesn't make, that's not gonna gain much of the efficiency that way. And I think the way that we're looking at it is that's just a minimum test that you must do, because internal short, external short, the thermal events, the corrosion tests, those are very basic environmental, physical, mechanical, electrical tests. So I don't think there's any way around it to make it smarter and so on. I don't think so. I think these are very fundamental abuse scenarios that perhaps we need more than less. And the thing is, we can do at the cell level test, right? And then you have a module level and then you have a pack level. So being able to do that at each stage of the production gate, if you will. Yeah, I'm not sure, David, how we can improve other than building more facilities to do that.
Well, then the next question is, as we make advancements in batteries, for example, one of the main things we're testing for is what happens when it shorts. And so a main innovation would be solid state batteries, which have a physical layer to prevent shorting. And so as you see these new technologies come online, how do you see testing evolving? And do we need to make new infrastructure, or how will that play out in America or Asia?
Well, if you look at testing, what testing is, you're trying to simulate a real world situation, right? So all these type of, testing for the abuse scenarios, I don't think it's going to change no matter what kind of chemistry it is. Solid state folks can say, hey, this is safe, but you have to
Mhm.
prove it.
Mhm.
And only way to prove it is to test it, and then show with the numbers and statistics that yes, it is 30% safe or 50% safer. You need to have a data
Mhm.
from test. For sure, it'll be safer. Everything, the all the technologies that are coming up, the LFP side is safer. The solid state is going to be safer. You have a different separator technologies now that are going to make it safer. So the safety is improving, but I'm not sure whether, they were able to validate their claim with the numbers. So I don't think it's going to change.
Mhm.
Just because we have a safer test, we have a less testing. I don't think that works that way.
That makes sense. So I'm just curious then, like, you have the materials engineering background, and you're leading this company. You're very interested in the business side of things. So I'm just curious, kind of what motivated you to enter this battery industry, but take it on from a new perspective, and lead this company and bring that knowledge to the U.S.
It's so I've been in the testing TIC industry all my career after my school. I was with a testing equipment company, testing labs, and I was also involved in business development in Asia, from Korea to China to Japan and Asia. I also worked in Europe for a couple of years. We knew that the battery electrification is going to happen
Mhm.
sooner or later. Obviously, in the United States, the battery electrification was started about a decade ago, as you all know, right? So that we
Mhm.
had a Volt for a long, long time. I mean, the first battery factory, the LG Chemical built in Holland, Michigan, was a decade ago.
Mhm.
We just didn't take off. It was going to take off, and then nothing happened. But this time, I think it's for real. So
Mhm.
just looking at the temperature between last year and this year is so different. Now, not only a lot of OEMs are pledging to say they already planned the EV transition with all their models that are coming up. Tesla doing wonderful. Even the Japanese, right? I mean, they're betting on this hybrid so long, but now they are also transitioning into the full electric vehicles, and Toyota is saying that they're going to have it. It's a great time for the electrification. And the fact that, my background of an engineer, but also businessman, but my ties to Asia. So I have a lot of connections in Asia, and then, being able to bring them over to the United States, I think that's very exciting. But at the end of the day, we need to do this for the United States. And that's so important that, although I'm an immigrant myself, but my children are Americans. So I'm doing it all for them. But so it's an exciting time. And that's how I was able to get into to the battery vertical.
Maybe while we're like zoomed out to KTON and your vision and the reason why you joined, maybe we can also talk about the other bucket, as you said, with the battery repurposing and recycling battery materials. And so maybe you can just start us off by saying, why is recycling batteries important? And then what role will KTON play in that life cycle?
Yes, I think one of the issues in terms of the circular economy and sustainability, it is material recycling, right? I mean, United States, we do not have all the raw materials coming from China, Australia, and now it's Canada. Ontario is booming because of that. A lot of companies are finding homes in Ontario for the material side of the battery industry. So it's important. I mean, even now, I think the reason that we cannot make batteries fast enough, but enough quantities already, is because of the shortage of the raw material. So it's important that we recycle every single batteries. So California EPA last year has gone through year-long study, or say the industry leaders got together to kind of come up with a way to make sure that the recycling is done correctly. If you look at currently anything in the battery side of recycling, it actually costs money for people to recycle. If you have your batteries from your notebook, you want to recycle, you have to go pay money to do that. So in order to create that more of a recycling, the government has to look at it from a different perspective. You have to make sure that it is profitable, it is commercially viable industry to have it recycled. So in the United States, there are quite a few names that are front runners in the lithium-ion battery recycling. It's not the lead acid, all the small. I mean, that industry existed for 100 years. Now it's the lithium-ion batteries, and the fact that each skateboard has 10,000 times more batteries than your notebook. So it's very important to have that all recycled. The thing is, in the lithium-ion battery recycling, one of the big pain point is the fact that these are once in the first step in recycling is shredding. You have to shred them, right? So you have to get it all to the cell level or module level, and then you have to go through the shredder. And the problem is, if you shred them, you're creating an internal short already. You're doing a real-time nail penetration there. So it's going to catch fire, it's going to explode and things of that nature. So, we have a technology where we can rapidly discharge and then terminate. So these are type of technology that are available from Asia already. So as you can imagine, they've been doing this for 2 decades. So the level of expertise, the level of sophistication is there. We just need to adopt it. In the United States, many of these different recycling companies, they just have a very unique approach to their operation. That's because they're all startups. And then if you're a startup, you have to differentiate from other competition, so the investors back you instead of them. So everybody has a different, methodology in terms of recycling. So we are still at that stage, right? And everybody is kind of running, and then, who's going to win? The time will tell. But until then, everybody's going to approach in a different fashion, simply because of the startup, the investment, that structure. So they simply cannot just copy what's been being done overseas for 2 decades. They have to come up with their own strategy. They have to come up with their own technology. So then, if you think about it, like it's like you're reinventing the wheel here in a little bit, because you have to claim your unique technology. So I think that's a little bit of a uniqueness in the US, because we are all entrepreneurs, right? We all wanted to do things in a different way. But recycling, that's very important. So because of that, David, I think one thing that I think is that I'm sure you know this very well, in the battery life cycle, right? We always talk about the first life batteries. When the batteries come out from a vehicle, that battery is still 80%, 70%, the health is left in it.
Yeah.
Right? So you want to use it for the second life application and so on and so forth. But I think, we have a much bigger need to just recycle right away, because you do not want to have that raw material sitting on somewhere as a second life battery. I think the industry is in such a need whether they need to go
Hmm.
from the new battery recycle right away again and again. So we're gonna have to waste that life left in as first life batteries. That's simply because we do not have the raw materials
Yeah.
in the US. And then I don't think we're gonna go and do much of a harvesting in the lithiums and so on. So we have to recycle.
Yeah. And so when you recycle a battery, I think the first thought that would come into mind for many people would be, could we tell the difference between pristine and recycled material?
Well, I think some companies claim that the recycled materials are better. So,
Oh.
um, so yeah, that's beyond my
Hmm.
expertise. I'm not in that refinery aspects of raw material extraction. We evolved all the way up to the black powder, but after that we leave it up to the actual the chemists.
Hmm. Yeah, I think from research I've read, it's basically like it's all due to like chemical potentials within the cell. And so once if you can separate all of the materials out and then just redo it, there's not any energy like in the NMC. It's because the NMC has a reaction with the other side. And so if you can create like your pristine, separate out all the ingredients, then you can just redo it and it's good as new. And so that was also my understanding from what I've read. And so just
Yeah,
checking with you.
that's my understanding as well. Yeah, you can
Okay.
recycle. I
Yeah.
don't know whether you can recycle perpetually, uh, but we'll see.
Yeah. And I think that's a really interesting point. And so I think that for NMC specifically, there's a lot of demand for high use and where energy density is very important, such as cars. And then you're talking about second life batteries where energy density isn't as important. And so we can see the rise of other types of batteries that may have a bigger footprint, but could last longer under less stress. And so from KTON's perspective, you're going to be having a flood of all these different chemistries eventually. How can we produce infrastructure to recycle all the different types of chemistries? Or how does the next 20 years look like in terms of how KTON will approach the recycling and reusability of batteries?
Again, our job from a technology partners we have from Asia in
Hmm.
terms of recycling is in that rapid discharge aspects of it, because
Hmm.
everything else is an actual, on infrastructure, right? It's a refinery of chemical factories, either it's hydro or pyro metallurgy. That's a technology that already exists, right? It's not something new. It's just the mechanics of how we recycle is more important, and different chemistries, as you said. That's up to the chemists at the refinery side how to do it. But I think those are not new technologies, right? So the actual refining aspects of black powder. So Katon, the technology that we're bringing in, whether it is a testing, obviously testing is chemistry agnostic. Doesn't
Hmm.
matter what format, what chemistry, it's the same type of use scenario that you're going to have to run through. So the equipments that we are providing, it doesn't matter what chemistry. As far as the manufacturing, the chemistry really doesn't matter because it is all depending on whether it is prismatic, it's pouch and so on, that aspects of it. Obviously, the front end of the mixing, the wet chemistry, the dry electrodes, those are gonna change. And in terms of there's testing, there is the manufacturing machine. So anything that's machinery wise, other than the chemistry aspects of the mixing, the front end of the manufacturing of the cells, that's gonna change. But the rest is the same, right?
I'm just wondering then, Fred, like, what are you most excited about, down the line, based on all of this, like, involvement, your experiences within the battery industry, maybe working with startups, like, what is most exciting to you, whether that's revolving around battery testing or just the battery industry as a whole?
What's most exciting? Finally, the U.S. is turning into the electrification. A lot of government side, not only the federal government but the state governments, they're very excited about the electrification. Everybody's fighting. If you look at the map of where all the cell factories are going, all the EV factories are going, I mean, it's no longer a one state that's hub for automotive. It is almost all states other than, maybe Colorado or, Missouri or somewhere there. But even from, California to Nevada to Oklahoma, Phoenix, go down to Florida, Georgia, Alabama, South Carolina, North Carolina, Canada, Kentucky, just, Tennessee, Ohio, Indiana, Michigan. It's all everywhere is an electrification epicenter now. So the entire United States will be benefiting from all the job creations from the new factories that are coming into the states. We will have all these people benefiting from the evolution to the electrification, not only the electric cars, but anything else, right? Anything that's mobility wise. So it's an exciting time. But again, we have to make sure that it is safe.
Absolutely. I love that. And maybe just to wrap up this episode, so our audience is materials engineering students or just enthusiasts as a whole. So since you have that background, but you also have, a very diverse background, what is maybe one thing you would like our listeners to take away from your career and experiences? Maybe one piece of advice.
I don't know whether, well, I'm an engineer, but, I'm now squarely a businessman. So looking back, what would I have done differently knowing where my career led to this point now is understanding more of the finance side of the business, for example. I think engineers, we are, we know how to calculate, we know how to model, we know how to simulate, we know how to run tests and designs and so on and so forth. But at the end of the day, if you are going to be a successful business person, you really need to understand the finance side of the business. And perhaps one thing that's more important is really to understand the human psychology, because at the end of the day, it is not a one single engineer who's doing something. It is a team effort. You need to work with people. You need to be a good people person. You need to be empathetic to others' pain. You need to willing to accept and work with other people. That kind of, the basic human quality. It is so important. As an engineer, you think that you are the smartest person in the room, but that's a wrong attitude, right? So having that human quality, I think is one thing that if you ask me now, what's the most important thing then when I look at somebody, it is not about their brain power. It is about their people power.
For sure. And I think that almost ties like hand in hand, right? Being able to understand someone else's motivations, like that's a reason for why you should learn the finances, right? Like if you're an engineer trying to recommend a decision is made, and it goes up to the business or the upper management, then you have to think about cost savings or revenue generation and things like that. So that's kind of maybe what you're trying to get at too. But I totally agree that empathy is a huge, characteristic that's required to be successful no matter what you do.
Right. And then, again, the behavioral psychology, you need to understand how people behave. As a business, you need to understand how the consumers behave, for example, right? Because it's not because your thing is better, technically, it doesn't really mean that's what people want. So understanding that psychology, the behavioral psychology, I think those are very, very important as well. I mean, you can hire a CFO, right?
For sure. Awesome. Well, thank you so much, Fred. This was very enjoyable, and I learned a lot about the US space and the battery industry as a whole worldwide. So really appreciate your time.
You're very welcome. Thank you again for inviting me.
As a materials engineer, we can make an impact in nearly every single industry. But with that versatility comes a lot of different options to choose from. So if you have no idea which industry or position is right for you, believe me, you're not alone. I've been there, done that. But just for a moment, imagine narrowing down your ideal role and company by the end of this week. Imagine being able to secure your dream job offer without having to apply to hundreds of job openings. Our online course, MSc Academy, includes video testimonials, resumes, interview prep, and mentorship from materials engineers who have been in your shoes. We also connect our members with companies and industry professionals in our expansive network to help accelerate your job search as much as possible. To learn more and get started, simply click the link in the description below. And if you enroll within the next 24 hours, we'll add 3 bonus career development resources. I hope to see you there.